All right, and we are going to continue our conversation about solving proportions, but in today's lesson, and that would be Unit 6, Lesson 3, and that can be found on page 29, we're going to work with proportions that result in a quadratic relationship. All right, so we did linear proportions last time, or proportions, I should say, that lent us to a linear equation once we started solving, and today we're going to look at what happens when we get a quadratic relationship. So you can see that wraps up our standard 12 here. This is 12.4. I can use proportions, solve problems involving quadratic relationships. So to get you thinking a little bit about quadratics, go ahead and pause the video, do the opener, flip it back on, and we'll see how you did. All right, so the big idea is that we still solve, all right, initially the same way. So we use what we know about proportions to set up our equation. So I'm still going to cross multiply here. So x times x, all right, that gives me x squared, equals, and then I do 5 times 20, and that is 100. Now, here I know, all right, that it is quadratic, all right, because we get, all right, x squared. So when the highest power of x is a 2, when it's x squared, we know it's quadratic. All right, now there's a couple of different ways to solve this, all right. Okay, so one way is just to think about it in a common sense way, right? So square means times itself. So what number times itself, all right, is 100. All right, and so that would be 10 and negative 10. All right, so we get two solutions. Okay, so remember, to get a positive number, there's two ways to get a number, a positive number when we multiply: a positive times a positive and a negative times a negative. That's why there are two solutions. Now, if you didn't, I put 100 here, and that should be 10. All right, so just plus or minus 10. Now, the other thing, all right, would be to take the square root of both sides, right? So take the square root, all right, okay, on your calculator, and you would also get 10. Now, on your calculator, it only gives you the positive root, so you have to be aware that there's another solution here, which would be negative 10. All right, so just a quick refresher, all right, on solving quadratics, and we say this is solving with square roots. Now, let's look down here, notes on solving proportions with quadratics. So once again, we're going to still start the problem using that cross product property. So we don't really care, all right, what type of proportion we have. If we have a proportion, this is how we're going to get started. Now, when we think about how to solve quadratics, we really have three methods of solving, right? And so the first method is solving by square roots, which is what we did in the opener, all right? And this is really what we did most of the time for a lot of our solving in Algebra 1. We solved with square roots, all right? Then we also can solve by factoring, all right? And when we factor, remember, we want ax squared plus bx plus c is equal to 0, all right? And then the last thing is the quadratic formula, all right? And that is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, and just like what we do when we're factoring, we want to be ax squared plus bx plus c is equal to 0. Now, this is one of the most fundamental things that we do in algebra, is that when we solve, it is always equal to 0. That's one of the reasons we did everything in Algebra 1 equal to 0, to get you in that habit. All right, so technically, you kind of skip that step a little bit when you're solving linear equations. All right, you don't really think about it, but you have to get a linear equation equal to 0 too, otherwise it doesn't work. So this is why we put so much emphasis on solving, all right, being equal to 0, all right, because once you get into any higher level problem, that is a must. All right, so what else do we need to remember about solving quadratics? So a couple of things, all right. So the first thing is we get two solutions, right? Okay. All right, so we get those two solutions, so we have to remember that, right? So whether I'm factoring, whether I'm using quadratic formula, whether I'm solving by square roots, we're going to get two solutions, all right? And so we'll need, and I'm going to put here, check both, all right, to see if they works, all right? So it's just a good habit, right? That's also a double check on your work, get two solutions, and then we always want to make sure it's equal to 0 before we start solving. All right, so make sure it's equal to 0 before solving. Okay, all right, so that's really a quick review. Now, what I'm going to do is just go through like 3 problems with you, all right, and I'm going to show you one with square roots again. I'm going to go through one factoring and then one quadratic formula problem. Now, understand that we are not grading which method you use. We're just grading can you solve, All right. Now it's going to be to your advantage to be good at all three. All right. And you'll see why as we go through some of the lessons moving forward. Okay, so let's flip the page and let's go to page 30, and let's just go through, all right, problem, actually let's go to problem 2 here. I was going to do problem 1, but let's go to problem 2 here. All right, and let's look at this. Now, once again, we see that it's a proportion, all right, so we're going to use that cross product property. Let me try to make this a little bit better focus for you, all right, to get started. And so I'm going to do 3x times 5x. So 3 times 5 is 15. X times x is x squared. All right. And then 10 times 6 here is 60. All right. Okay, now here, all right, we can go ahead and divide both sides by 15. And we get x squared equals to 4. All right. And then we can take the square root of both sides, and this gives me x equals plus or minus 2. All right, and there's both solutions. Now notice if I go back and plug 2 in here, I get 10 over 6 equals, and if I take 2 and plug it in here, I get 10 over 6, so that one works. All right, if I plug negative 2 in, notice I get negative 10 6 equals negative 10 6. So both solutions work. Okay, it's okay to have a negative number equal to a negative number. I know sometimes that seems a little weird to students, but it's okay for it to have a negative ratio. All right, so there's the first one, solving by square roots. All right, now let's go down and look at number 4 here. All right, so this one's a little bit longer in process. All right, and you'll see why as we go through a couple steps here. So once again, we're going to start number 4, all right, using that cross product property. So I'm going to cross multiply here. Now I'm going to write this out as x times x plus 6 just so I can make sure I emphasize my distribution here. And then I do 1 times 7 here. And that gives me 7. All right, now once again, I'm going to distribute this x to everything in our parentheses. So x times x is x squared. X times 6 is 6x. And that is equal to 7. Now notice this is now different from our prior problem because normally if I'm going to solve by square roots, notice I have just an x squared term and a constant. And that means I can solve by taking a square root. Notice now we have our x squared term, we have our constant term, but we also have our b term. We have that bx term. And when you have that bx term, what that means is now we have to factor each quadratic formula. All right. In Algebra 2, we'll teach you how to complete the square, which is another method. All right, and you could do that. But till then, all right, once you see that we have an a term, a b term, and a c term, that now means we need to jump into factoring of the quadratic formula. Okay, so what I'm going to do now is, remember, we need this to be equal to 0. So I'm going to subtract 7 from the right side here and the left side. Okay, now notice on the left side, there are no other constants to subtract 7 from, so I'm just going to bring it over like that. All right, now, what we're going to do now is our area model, which is really just a physical representation of factor by grouping. All right, our a term always goes in the upper left. Our c term, which is our constant term, goes in the lower left, or excuse me, lower right. Now, our pattern, all right, okay, is we have to do 2 things here. Okay, the first thing is we always have to do a times c. All right, so a is 1, c is negative 7. That gives us this number here. And we are always going to add to get to our b term. So we need to get to a positive 6x. Now, the reason we do a times c first is because we have to find the factors of a times c that add to be this b term here. All right, and so the factors of negative 7 that add to be positive 6 would be 7 times negative 1. So notice 7 times negative 1 is negative 7. And then 7x plus negative 1x, that is our positive 6x. So what this process is doing, if you think about FOILing or multiplying, is we know we had to combine 2 terms to get to this. This is the pattern that gives us those original 2 terms. I'm going to put the 7x here. I'm going to put the negative 1x here. Now, once again, it does not matter which box you put those terms in. You will get to the right answer eventually. So if you put the negative 1x here, 7x here, it'll all work out. Now, all right, this just gives us a physical representation to look at for our greatest common factor. So when I look at my first column here, my greatest common factor is x. All right. When I look at my second column, my greatest common factor is a positive 7. All right. When I look at my first row, my greatest common factor is an x. When I look at my second row, Notice both numbers are negative, so I can take a negative out, but then the GCF is just 1. All right, it's just 1. Okay, so now I can see my factors here. All right, so this factors into x plus 7 times x minus 1 is equal to 0. All right, so remember the result here and the result here are two factors. And then I can take both of those and set them equal to 0. So x plus 7 is equal to 0, and x minus 1 is equal to 0. This means one solution is negative 7. This means the other solution is 1. All right, now, once again, if we plug them in and double check them, if I plug negative 7 in here, I get 1 over negative 1. If I plug negative 7 in on the right side, I get negative 7 divided by 7. And so notice I get negative 1 equals negative 1. So that solution works. So this is a good solution. Notice if I plug 1 in here, all right, if I plug 1 in here, I get 1/7 on the left side. And if I plug 1 in here, I get 1/7 here. So 1/7 equals 1/7. So that is also a good solution. All right, so once again, it's good to get into that habit of going back and double checking your work. Okay, so let's go ahead and, all right, flip the page, and let's go to, all right, problem 7 here on page 31. All right, now, I'm going to go through one problem with the quadratic formula just so you can see it. All right, you don't have to use the quadratic formula unless you can't factor. All right, but there are certain times where maybe you can't factor, or the pattern is so complicated it takes so long to find the combination that you might be, all right, able to get through the quadratic formula a little bit faster. Once again, okay, we're going to start with our cross product here. All right, now once again, it doesn't matter which cross product you start with, but I'm going to start with 5x times x plus 7 equals, and then I'm going to cross multiply here, and I get negative 4 times x minus 2. All right, now once again, I'm going to distribute and make sure I get to everything inside of those parentheses. So I get 5x squared plus 35x on the left side equals, all right, negative 4x plus 8 on the right side. Okay, now once again, I see an A term, a B term, and a C term. So this tells me that I'm in quadratic formula or factoring territory. And I must get it equal to 0. So I'm going to add 4x to both sides. And once again, I'm going to subtract 8. And notice there's nothing to combine it with, so I'm going to kind of squeeze it in there at the end. So 5x squared plus 39x minus 8 is equal to 0. Okay. Now, like I said, you can totally factor this. All right, it works. But I wanted to run through one quadratic formula problem just so you can see it in case you need to use it. So when I look at this, notice that A is 5, B is 39, and C is negative 8. All right, if I go back to our original page here, now what I want to do is plug, all right, A, B, and C into, all right, our quadratic formula. So if I do that, all right, I'm going to just come right up here. This is x equals the opposite of b. So now it becomes negative 39 plus or minus the square root of. All right, and then it's going to become b squared minus 4ac. All right, and make sure you get parentheses around everything. All right, over 2 times a. All right, so x equals. All right, I'm going to pause the video here and grab my calculator. All right, so I am back. I had my calculator in my backpack, had to grab that. So now, all right, I'm going to just take and just put all of this into my calculator, so including the parentheses. So 39 squared minus 4 times 5 times negative 8. And that gives me what's under my square root radical, so 1681. So negative 39 plus the square root of 1681, and that's all divided by 10. All right, now I'm going to take the square root of 1681, and that is 41. All right, so negative 39 plus 41 divided by 10. And I left my plus or minus off here. All right, and that's important because once again, we get those two solutions, right? So x equals, and I'm going to break it apart here, negative 39 plus 41 divided by 10. And x equals negative 39 minus 41 divided by 10. All right, so now negative 39 plus 41 equals, and if I divide that by 10, you can see that I get 2.2 for one solution. On the other side, I have negative 39 minus 41, and I divide that by 10, and I get negative 8. So x equals 2, negative 8. So there are your two solutions. These are also the two solutions you would have, all right, found if you had factored this equation as well. All right, so there's a quick run through on solving proportions with quadratics. Go ahead and finish the rest of the lesson, and I will see you next time.